How does a refrigerator move heat against flow? Imagine opening your refrigerator and feeling that rush of cool air. Have you ever wondered how it keeps your food cold while moving heat to the outside? Let's break down the fascinating process behind this everyday appliance. A refrigerator works by moving heat from a cooler space inside to a warmer environment outside. This process goes against the natural direction of heat flow, which typically moves from hot to cold. To achieve this, refrigerators utilize a refrigeration cycle that involves a special fluid known as refrigerant mechanical work and phase changes of the refrigerant. First, let's talk about the refrigeration cycle. This cycle consists of four main components: the evaporator, the compressor, the condenser, and the expansion valve. Each part plays a crucial role in moving heat where it needs to go. Inside the refrigerator, the refrigerant enters the evaporator as a low-pressure, cold liquid. Here, it absorbs heat from the interior of the fridge. As it takes in this heat, the refrigerant evaporates and transforms into a gas. This evaporation cools the air inside, keeping your food fresh. Next, the refrigerant gas travels to the compressor. Think of the compressor as a pump that compresses the gas, increasing its pressure and temperature. This step requires electrical energy, which is the work needed to move heat against its natural flow. Once the gas is compressed, it moves to the condenser coils, usually found at the back of the refrigerator. In the condenser, the hot, high-pressure gas releases the heat it absorbed earlier to the surrounding air. As it cools down, the refrigerant condenses back into a liquid. After this, the liquid refrigerant passes through an expansion valve or capillary tube. This sudden drop in pressure causes the refrigerant to cool down significantly before it re-enters the evaporator to start the cycle again. This entire cycle repeats continuously, effectively transferring heat from inside the refrigerator to the outside environment. It keeps the interior cold and your food preserved. In thermodynamic terms, a refrigerator operates like a heat engine running in reverse. Instead of converting heat into work, it consumes work or electrical energy to move heat from a cold area to a hot area. This process is governed by the second law of thermodynamics, which states that heat naturally flows from hot to cold. The principles behind refrigerators also apply to air conditioners and heat pumps. These devices use similar cycles to control temperatures by moving heat against its natural flow. Understanding how refrigerators work can help you appreciate the technology that keeps your food fresh and your drinks cold.